Here's a Chapter 6, Lesson 6 mini video lesson on solving absolute value equations. We talked about earlier this year about solving absolute value problems where if you take the absolute value of 8, you get 8, and if you take the absolute value of negative 8, you also get a positive 8. So when we solve equations, we have to take that idea into account. We have to remember that whatever's inside the absolute value sign can have a positive value or a negative value and still equal a positive answer. For instance, the one that you're looking at right now, the absolute value of x minus 8 equals 14, that expression x minus 8 could have a value of negative 14 or it could have a value of positive 14, and when you take the absolute value of it, you'd still get a positive 14 answer. So to solve an equation like this, what we're going to do is we're going to create two mini problems, two mini little equations. We're going to set x minus 8 equal to 14, and we're going to do x minus 8 equals the opposite of 14, the negative 14. So you kind of take this equation, you break it up into two different mini equations. This is to take into account that it has both a positive and negative value. So when we solve it, you'll add 8 on this side and add 8 over here. You get a value of x equaling 22. And on the right, when we add 8 to this side and we add 8 to this side, you're going to get a value of x equaling, looks like, negative 6. So what we're saying is that x could be both 22 and negative 6. You could put both those answers into this equation right there, and when you take the absolute value of it, you'd get positive 14. Try it out. 22 minus 8, that's 14. Absolute value of 14 is 14. And if you throw negative 6 in for x, negative 6 minus 8 is negative 14. Take the absolute value of negative 14, you get 14. So your two answers are 22 and then a negative 6. You could just kind of list the answers. Something like that would be fine. All right, I want to show you one other problem that's just kind of like this, but something else unique happens in this problem. This looks a lot like the one we just did, but the difference on this one, maybe I should do the highlighting tool here, is this negative 4. Whenever you have a times or a division or addition or subtraction part that's next to or in front of or on the same side of the equation as your absolute value symbol, you need to get rid of it before you can get rid of the absolute value sign. The absolute value sign is sort of a grouping symbol, and so we have to kind of keep that in mind as we work through this problem. So here's how I would solve this problem. To get the absolute value sign to be by itself, I'm going to first add 4 to each side of my equation, each side of my equations. And when I do that, then 4's cancel out on the left, leaving me with the absolute value of 3x minus 2 equals 10. Now that this absolute value sign is all by itself, there's no times, there's no addition or subtraction piece in front of it or behind it, we can now split this problem into two parts, kind of like we did the last one, and set it equal to positive and negative 10 for this example. So 3x minus 2 equals 10, and 3x minus 2 equals negative 10. And now it's just a matter of solving it to find the two values or the two roots that would make this true. So I add 2 to both sides, and I get 3x equals 12. Divide by 3, this x equals 4 on the left. Over here I'll add 2 again to get rid of that negative 2. That gives me 3x equals, looks like, negative 8. Divide by 3 on each side, and x is going to be negative 8 thirds. So my final answer here is 4 and negative 8 thirds. It's not an ordered pair, so we don't have to put parentheses around it, but you can circle your answer, box it, whatever you like to do on your assignment sheet, and that'll be lovely. Hope that helps. In case you get stuck tonight, good luck.